Hello, class. This will be the recorded lecture for section 9.2. I think I'm going to split it up into two separate ones. And this is a first introduction of hypothesis testing with actual calculations. And so there's a couple different scenarios. In the first scenario we introduce is this idea of hypothesis testing, where for a population mean, where again, the standard deviation is null. So you can see how it kind of relates to the confidence intervals that we talked about in the last chapter. And so in this idea, we're going to introduce two techniques. One, the book calls the critical value comparison, and that is Z-scores, which I actually kind of like personally. And back in the day, that's how we did it. And then we also do what they call a p-value calculation, and that's calculating probabilities now using normal distribution with the central limit theorem. And so again, all these calculations are predicated on the fact of the central limit theorem idea. And that's why I said that is such an important theorem. So this difference between the two is the critical value, which deals with Z-scores, and the p-value, which stands for probability calculations using the normal distribution. So the first thing we're going to do are the Z-scores, which I actually personally like. So let's take this as an example, and we'll walk through this calculation where it says, the College Board reported in recents that the mean SAT was 550 with a standard deviation of 160. Population mean, population standard deviation. And results of an earlier study suggested that the mean score was 530. And a teacher who runs an online coaching program thinks the students coached by his method has a higher mean score than this. Because the teacher believes that the mean score for a student is greater than 530, here is our null, and here is all our alternative hypothesis. Again, the null is kind of nice, it's always equal. So in this case, what we want to prove is we want to reject the null hypothesis, because obviously if you're running this coaching, you want to say, hey, I do better than the mean, right? So how do we set this up? Well, here's the idea. Is that, say like we take 100 students and roles in this coaching program, and they take the test, and now you have some data, right? And so here you see that the data is 562. So the question is, can you reject the null hypothesis, or do not reject given this data set? And so the idea is that we need to figure out with regards to this idea of what's called a test statistic. And then we're going to set up a confidence style calculation to see if we should accept or reject or do not reject the null hypothesis. So you remember when we set up the Z-scores. So our original Z-score setup was the actual value minus the mean divided by the standard deviation. And so now what we're doing in this calculation is we're going to change it slightly, but same style concept. So this Z, which they use as the critical value calculation, is going to be the mean of our experiment. So in this case, that's the X value, and we're going to subtract it from the null hypothesis. So this comes from the null hypothesis. And guess what we divided by? The standard deviation divided by the square root of n. And that's where the central limit theorem comes in. So if you're, we had this set up where the null hypothesis was 530, and we hope that the alternative, they use 1. If I use A sometimes, I apologize, is 500, greater than 530. So this would be a great tail test, right? So if you think about it, we're looking for this values that are over here. So we had 562 for the mean, and there was 800 students that were used in our sample. So plug all these numbers in. Let's see what we get. 562 minus 530 divided by, again, the population standard deviation is known, and that's what you use. If you go back to that, it's 116. So that would be 116 divided by square root of 100. So you get out your calculator and you see this is 2.76. That's a pretty high z-score, right? It's almost 3 standard deviations away from the mean. And when you take a look at the calculation here, you can see the same one as we got in the book, but the book has a nice little graph here, right? So if you think about how far you are from the mean, you're almost 3 standard deviations above the mean. And so that is quite strong, actually, right? With regards to that. And if you remember, we set this up where you had certain z-scores, right? And so let me redo this a little bit and set it up here so I could. So you remember when we did a 90% confidence level, right? So you remember what that z-score was, 1.645. And so that was 5% here, right? So that would be pretty small, right? And the book, remember, used this crazy term called unusual, less than 5%. And I always said that's a weird thing. I would use more the term unlikely to happen. And so that's what we mean by these critical regions and critical values. Is the idea is that if it's a small percentage over there left in the tail, then you feel highly confident that you could reject the null hypothesis because of that. I think I said that quite well, but let me say it again because that's important. So this unusual, which I like to use the word unlikely, they use 5%, which is typically a good number, right? That you have just 5% possibility, right, with the testing that you're going to be wrong, right? That there's going to be a data that's in there. And so the idea here is that if the critical region is small like that, 5% or less, then you could say by this testing, you could reject the null hypothesis and the alternative hypothesis is true. And so you could see here is that if we do the 5%, right, that is 1.645. And you could see that the z-score here of 2.76 is well above that, right? So it's even smaller than 5%. And so you should feel very comfortable that you could reject this null hypothesis. So I paused for a second to pull up the z-score table. I thought I had it up, but obviously I didn't. And so how do you know what that actual probability is? Well, you could take a look at the z-score, right? And so if we go back to our 2.76 and look on our z-score table, it's 2.7. And the sixth is 1, 2, 3, 4, 5, 6. So it's this one right here. So if you go down to 2.7, you get 0.9971. So what does that mean? All right, well, if we go back here, this, let's see here, let me get a different color here. Let's use this color. So this would be a z-score of 2.76. And what was that total? From the total all the way down was 0.9971. So what is this up here? It's 1 minus that, right? 0.9971. And so let me get out my calculator to do this real quick. 1.9971 minus. So you could see this would be 0.0029. And so that's only 0.29%, right? When you move the decimal point twice. So that is a super small possibility of this being incorrect. So you would feel very comfortable rejecting this null hypothesis with the experiment and the data that you actually did. And you can see that what's a critical value here is you do need to know what the population standard deviation is. And so when you take a look at this, we'll have three different possibilities. You're going to be less than, which is the left-hand test. So then you're going to get a Z value that's negative. And so the idea is that when you look at the Z value, you want that to be less than whatever critical value that you're comparing it to. And then the left tail, you want it to take a look at just a right tail, just like we did. You hope that the Z value is greater than that. And when you do the two tail, you have to take a look at both sides, right? The low end and the high end. This table again will become very useful. And all books use this significance level as this term alpha. And so the idea is that it's random. You know that the population and standard deviation, and you have a sample size greater than 30. So we can use what? Central limit theorem. So here's this idea, two tail and one tail test with regards to that. So here are Z-scores for the left, here are Z-scores for the right, and then here are Z-scales for the two test. So quite nice with regards to that. So this is in slide 13. That will be appropriate Z-scores when you run this test. So let's do one more example. And so this one here states that the Automobile Association mean price of a gallon of gas in LA in January of 2017, $2.82. And so they recently taken a random sample of 50 gas stations, so it's greater than 30, and the average price was $2.77. And so here we go. You have to have the standard deviation of population. So again, typically you don't have that, but here we always start with this. And then an economist is interested in determining whether the meat price is less than 282. And so we use this critical level now, since it's less than 282, right? We have equals for the null and alternative is less. We could do this calculation with regards to that. So this is going to be a left tail test, right? And so when we set this up, what do we know? And again, let me do this one on the whiteboard. So what do we know here? So we are given the following. We are given, we have 50 from our sample. We're given this crazy mean of 15 cents, right? And we're given that the null hypothesis is 2.82, and our alternative hypothesis is less than. So we're doing left tail test, right, with regard to that. And out of these 50, our mean was 2.77. So when you do the Z-score calculation here for the critical value, it's going to be the mean minus mu all over the standard deviation divided by the central limit theorem standard deviation of square root of n. So that would be 2.77 minus 2.82 divided by 0.15 divided by square root of 50. Again, if you got that out, you would see that would be minus 2.36. So again, a really small number for a Z-score. So if you're worried about this being 5%, all right, for our left tail, That's a z-score of minus 1.645. And you can see that this is quite a bit less than this. So again, the idea that you could reject this null hypothesis. And so that means that you would accept the alternative hypothesis. And so that's the ultimate goal when you run these tests, that would be a true statement. So I'm going to stop the recorded lecture. This is the kind of critical value, as the book calls it. I call it the z-score way of doing hypothesis testing. The next recorded lecture will talk about doing p-values or probability calculations for hypothesis testing.